use variation of parameters to solve the given system. So here's the given system. First, you need to rewrite it in terms of in the standard form of vector x prime, which is this, okay, which is this equation. So you take the leading coefficient of x and y, put it into a matrix, multiply by vector x, and then add the I would say the constant or the f of t, whatever the number that doesn't have x and y, doesn't have the variable. Okay, now first you need to find so in order to solve this equation, reversely you have only this part, and that gives you a homogeneous solution. Now it has this one, that means that you are going to have non-homogeneous solution. So first you need to find out the homogeneous solution first, and then figure out what the non-homogeneous solution later, then combine them together. So here is the strategy that I wrote down. So first you find the homogeneous solution, which without this one, it's the same as what you usually do. And then you are going to find the non-homogeneous solution, which I will walk you through step by step. So to find the homogeneous solution, first find a minus lambda I. Let's call this matrix A, and then subtract it with lambda I. That gives you this matrix. Then find its determinant. That gives you this. Distribute this out, simplify it, and then set it equal to 0. You find out, you will get lambda equals 0 and 1. Okay, so since this is 2 by 2 matrix, you will get 2 eigenvalues. Now for each eigenvalue, you will get an eigenvector corresponding to it. So take a look at the case when lambda equals 0, plug it into this one. That gives you this matrix augmented with 0. Okay, so from use either one of these equations to solve for the unknowns. So I can see that let's use the first equation. So if I have 3k1 equals 3k2, then k1 equals k2. If I choose k1 1, then k2 is 1. Then vector k is 1 1, and my vector x1 is 1 1. For lambda equals 1, plug it into here, augmented with 0. Okay, now you have 2k1 equals 3k2. Then solve for k2, I got 2 third k1. If I choose k1 3, then k2 is 2, vector k is 3 2, and then my vector x2 is 3 2. This one multiplied by e to the 0, which is 1, so which I didn't write down, but for clarity I wrote it down for you. I just wrote it down. Now let's write the homogeneous solution, vector x. So this represents homogeneous. So vector x equals c1 times vector x1, which is this one, plus c2 times vector x2. Okay, now it's time to find the non-homogeneous solution. From homogeneous solution, put this into matrix phi of t. So basically you take the vector xf, then constant c1 c2, and put it into a matrix, so 1 1, and then don't forget to bring down the e to the t as well. Okay, so distribute this in, you have 3 e to the t, 2 e to the t. Okay, now find the determinant of phi of t. That gives you this one, e to the negative e to the t, and then phi inverse phi of t, which is 1 over the determinant times. So for this one, you switch the position. So 1 to e to the t. So switch the position, and for this diagonal line, you just add the negative sign. Okay, and then multiply this out, simplify it. That gives you this matrix. Okay, now let's find vector u prime, which is inverse phi of t times f of t. Okay, so inverse phi of t is this, what we just found. F of t, what is f of t? Let's go back here. So f of t is this. Okay, so when you put it into the vector x prime, whatever time vector x is your a minus lambda, is your a matrix A, and then what left over is your f of t. So if I multiply them together, that gives me this matrix. Okay, I'm sure you know how to multiply the matrix C together, so I'm not going to go over the steps. Okay, now when you multiply this out, it gives you this one. Now you are going to find the integral. You are going to find the integral of u prime of t. So take the integral of this one, that gives you this. So integral of negative 11, integral of a constant is the constant times t. Integral of this one, e to the negative phi t, is negative phi e to the negative phi t. Don't forget to have negatives. Don't forget you divide by the constant here, because and if you want to double check, you can take the derivative of this, which should give you this one. So if I take the derivative of this, that gives me 11, negative 11. Take the derivative of this one, that gives me negative 5 times e to the negative t times negative 1, which is positive 5 times e to the negative t. Okay, we good. Now let's find x non-homogeneous solution, which is xp. So vector xp equals phi of t times u of t. Okay, so make sure you have it in this order. Do not switch the order, because multiply matrices is different from multiply, because the order of matrices is different from the order of numbers or variables. Okay, so if you switch the order of them when you multiply matrices together, that gives you a different answer. Okay, so phi of t is this. Okay, u of t is this. So multiply them together. Make sure you put them in the correct order. That gives you this. Then your final answer is equal to x vector x of h plus vector x of p, which is this one. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.